So this is just a review on speed. We learned about two types. So the first type was linear. So we talked about it's measured in distance per unit. So a good example would be like feet per second. So if this car travels around this, and let's just say it's going like 500 feet per second, we're using the word linear because if we took how far it went and we straightened it out, we're like straightening out the arc it traveled on, it results in a line of the same length. So again, linear speed measured in distance per unit. Versus angular speed, which is the rate at which something turns. So we're talking about the wheel specifically. It might be turning at 400 radians per minute. So those were the two types that we had previously talked about. So the first example is linear speed. The formula is shown here. It's V equals S times T. V is speed, S is arc length, T is time, and then it gives you an example, and typically you have to do some converting. So it says a truck travels at a constant speed around a circular track. I just like to draw some stuff. It just helps me like know what's going on. It says the circumference is equal to 4 miles. So this truck goes around one time. That's 4 miles. The car records a time of 15 minutes for 9 laps. So the first thing we kind of want to know is how far is it traveling? That would be our arc length. So if it goes around one time and that's 4 miles, we want to know how far would it go in 9 laps. And so that would be 36 miles. And so this gives us our arc length. So you got to know how far it's going first. Does that make sense so far? Okay. The second thing we need is time, and it's really nice because they give you the time ready to go. So if we want to know the speed, we just take how far it traveled, our S, and that's in miles, times our time, and that's in minutes. And so this thing would be going, sorry, I gotta get my calculator 1 sec. All right, formula fixed. I don't know what was going on. So let me just erase that. Everything else is fine up to this point. You're just dividing instead of multiplying. So 36 miles over 15 minutes. I'm just going to simplify my fraction to make it a little easier. I could divide both of those by 3. Let's see. And that would get me 12 miles in 5 minutes. Okay, but you're not done because it says how far or what's the linear speed in miles per hour. So you just have to do a small conversion. So 12 miles, 5 minutes. We know that there are 60 minutes in 1 hour. And then just remember, whenever you convert, whatever you're trying to cancel out, so I'm trying to cancel out minutes, they go on opposite sides of each other. So if one is in the numerator, the other goes in the denominator, vice versa. And then you can just multiply across the numerators. So you get 720 miles over 5 hours. And last step, if you divide, it will simplify. This one will just show you how to find just arc length, which we did in the last example, but it's just worded differently. So this says find the distance traveled, which is arc length, of a point that moves with a constant speed v along a circle in time t if v equals 6.2 kilometers per hour and t equals 4.5 hours. So this was our formula from last time. And you're just plugging in these items. So I have 6.2 kilometers per hour equals, I don't know S, and then I have 4.5 hours for my time. And if you were just going to solve this like a normal algebra problem, you would just multiply both sides by 4.5 to get those to cancel out. And so really you have 4.5 times 6.2, and that equals S. So shortcut on any of these problems, you're just multiplying those two together. So you get 27.9 kilometers. Last example is angular speed. So just a different formula written differently. This time speed is W. The central angle is theta. If you forget, central angles are formed at the center of a circle. So this angle right here is the central angle. And then T is your time. Another thing to remember is 1 rotation equals 2 pi radians. So if you have a circle, like our circumference per se, this would just be 2 pi. So this one talks about a lighthouse, and I'm going to just draw a circle. So the lighthouse is right here in the middle, and it's got this light coming out, and it's rotating around in a circular motion with a constant speed. The light completes 1 rotation every 40 seconds. And then it says, what is the angular speed of the beacon in radians per minute? Okay, so we just said 1 rotation is 2 pi radians. My time is 40 seconds. So this right here is my theta. This right here is my time. And I just plug those in. So W equals 2 pi over 40. If you simplify 2 over 40, you're going to get pi over 20. You're more than welcome to just leave it like that.